So now we are going to use this CAS diagram to actually identify why firstly do we call it a CAS diagram, and how do we plot our trig ratios to actually be in this CAS diagram, right? So the first thing we need to note is that our axes, here we have a positive y-axis, here we have a positive x-axis, here we have a negative y-axis, and here we have a negative x-axis, right? So let me say to you, let's plot sine of theta, right, which we said it's y over r from the previous example, right? So if we say it's y over r, which the y in this case is positive, how can we plot it in this diagram here? So we simply know that the y is positive, which means it's using this axis, right? And our r is always positive. So let's say, for example, what we can do is we can draw a line all the way here, which this would be our r, and then since it's theta and it's going to be sine of theta, we can say this is theta, and our y would be this one here, which is positive, and our r, which is this one here, is also positive. So this tells us that actually sine of theta lies in the second quadrant where it is positive. But let's say I said to you, I want cos of theta, which is equals to x over r, right? But if I said to you, you must find it in this triangle here of this angle, then the cos is x, right? So in this case, our x-axis is negative. So here it's negative x, right? So and then our hypotenuse is positive, definitely. So this means that now that our x in this quadrant is negative, so it's going to be negative x over r, right? So it tells us that our cos of theta is actually negative in this quadrant. So let's say, for example, I want you to identify tan of theta, which is equals to which is equals to y over x, right? So using the very same diagram, our opposite side of y is positive, right? But our x value is negative. So meaning that our tan of theta in this same quadrant is negative. Only sine of theta is positive. So now we know that in our second quadrant, sine is the only trig ratio that is positive. So let's go to the first quadrant, which is actually something that I should have started with. And let's say we have sine of theta, which is equals to y over r, right? And it is the first quadrant. So in the first quadrant, we can see that our y value is positive and our x value is also positive. So in this case, our diagram or our sine of theta is correct. So which means now that sine of theta is positive in this quadrant. So let's say I want cos of theta, which is equals to x over r. So according to this diagram here, because I can still draw the diagram for us to have a better understanding. So let me draw the diagram. And we have theta here, and this is our y, this is our x, and this is our r. So to find sine of theta, we're gonna say opposite, which in this case our opposite is y, which is positive, and our hypotenuse is always positive, so it's r. So this tells us that sine of theta is actually positive in this quadrant. And then we're going to look at our cos of theta, which is adjacent over hypotenuse. So the adjacent side is our x, which is also positive, and then our hypotenuse is positive. So this tells us that cos of theta is also positive. And then we go for our tan of theta, which is equals to our opposite side, which is y, over adjacent side, which is x. So looking at this very same diagram, our opposite side is this one, which is y, it is positive, and our adjacent side, which is this one here, it is positive. So it also tells us that tan of theta is also positive in this quadrant. So all the trig ratios are positive in the first quadrant. Now let's go to our third quadrant, which is this one here, right? Then we have our theta, which is this one, and then we do something like this, right angle, and let's say this is our y value and this is our x value. But remembering that our x value in this part it's negative and our y value is negative. Why am I saying that? You need to look at your x-axis and your y-axis. So in this case, our y-axis is negative y and our x-axis is negative x, right? So let's say I also ask you, what is our sine of theta, which is equals to y over r, right? But looking at this diagram here, our opposite using this angle here, our opposite of this angle it's negative y. Then our r it's always positive. So because it's negative y, so the y is negative, it means now that our sine in this quadrant it's negative, right? Then we go for cos of theta, which is equals to adjacent over r. So the adjacent side of this angle it's actually minus x, this minus x here, right? So because it's minus x and the r is positive, so which means here it's negative. So this confirms now that our cos of theta in this third quadrant it's negative, right? And then we go for our tan of theta, right? So tan of theta, which is equals to y over x. So our y value, as I said, it's negative y, and our x value it's negative x. So because these values are negative, so it's negative here and negative here, so if you divide negative you get positive. So therefore our tan of theta is actually positive in the third quadrant, right? So now we know that the third quadrant, our tan of theta is positive. Now we go to the fourth quadrant. So we draw the diagram first. Okay, so we draw the diagram first, the right angle triangle, and let's say this is theta and this is y, this is x. So y in this case is negative, but x is positive in this case. So let's say, for example, I want our sine of theta, which is equals to y over r. But looking at this diagram of theta, our y value is negative y. So it means now that our sine of theta it's negative here. So it's negative angle. So this confirms that sine in the third quadrant is actually negative, right? Then we go for cos of theta, which is equals to x over r. So looking at this diagram here, we know very well that the adjacent side it's positive and our r here is positive. So this confirms to us that actually cos of theta is positive in the fourth quadrant. Then we try tan of theta, which is equals to y over x. But looking at the opposite side, it's negative y. So you write negative there. And then the adjacent side is positive x. So because it's negative y, it makes the solution negative. So therefore confirming that actually tan of theta is negative in this quadrant. Hence, we see here in the fourth quadrant there's C. So basically confirming that only cos is positive in the fourth quadrant. So now we understand how we plot and identify the signs of our trig ratios. Okay, so now we are going to look at the angles of our cast diagram, right? So the cast diagram, you know, this is cos. This is all meaning all our trig ratios, your sine, your cos, and your tangent are positive in this quadrant. Then you have your sine here, which you can write as sine, and your tan, which stands for your tangent, right? So this is your cast diagram, right? So let's identify the angles that lie in each quadrant. So in quadrant 1, which is this one here, quadrant 1, all trig ratios are positive. So this means now that the angles that lie in this quadrant, it's 90 degrees minus theta and 360 degrees plus theta, right? So 90 degrees minus theta. So what I mean is any angle that is below 90 degrees, it actually lies within the first quadrant, and it must also be above 360 degrees, right? Hence it's 360 degrees plus theta. And then for our second quadrant, the angles that lie in our second quadrant, it's 90 degrees plus theta and 180 degrees minus theta, right? So anything greater than 90 degrees but less than 180 degrees lies in the second quadrant. Then we go to our third quadrant, right? Our third quadrant, we have 180 degrees plus theta and 270 degrees minus theta. So any angle that is above 180 degrees but below 270 degrees lies in the third quadrant. Then we have our fourth quadrant. Whereby angles that lie in this quadrant is 270 degrees plus theta and 360 degrees minus theta, right? So any angle above 270 but less than 360 lies in the fourth quadrant. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.